Hello, everybody. This is the final fall review. So, any notes taken here can be used on the final. You can use these notes to help you with any practice I give you, which will be extra credit on your final and on any other stuff from this semester that you need to bring your grade up on. So let's just get started. We're gonna go test by test, like topic by topic, the stuff that's gonna be on your final. So starting with our first unit from the first 9 weeks, we have topic 3, which was systems of equations. And things were out of order, so I know that confused some people, but we started out with topic 3. We're going very basic with this stuff. We are focusing on the graphing aspect of this, not even the algebraic aspect. So basically, Desmos, not doing it by hand. Remember that when we have one solution, that is when our lines cross one time. And so in this case, we see that our lines cross at 3, 2, because 3, 2. If it was no solutions, they would cross no times. Oh, that happens when they're parallel lines. And then we have infinite solutions whenever the lines overlap. So when they are the same line, this happens. So here we see find the solution to the following systems of equations by any method. So I will be showing you guys, since it says any method, since it does not specify a method, the easiest thing for you to do is graph. So we're going to graph, we're going to go to Desmos and do this, and I'm going to show you what I would put on my paper if I were a student and I was showing my work to Miss Sagas, what I would do, okay? Here I am in Desmos. I'm literally typing y equals 3 plus x, 3x plus 10. And my other one was 10x minus y equals 15. Alright, so I don't see anything, so I zoom out, and boom. I find that they cross here. So guess what? That's my answer. So if I'm to go back here, I would sketch a picture of the lines. Bruh. So what I would do is I would kind of sketch a picture of the lines super quick, whatever, with something like that. Notice how it's not perfect, but whatever that was. It was like 3.59 and then 20 point something. I don't remember. It doesn't matter. So that's how you would do that. And then we can do the same thing for the other one. But we're not going to do that one right now. We'll do that one later because that's a quadratic. But yeah, that's basically how you're going to do those types of problems. We also talked about matrices, and so you're going to see matrices again on your test. Now, remember that a matrix is that grid. Okay, so remember that when we made our grid, we had 2. All right, we had A, which had all of the coefficients, the numbers in front of the letters, and then we had a smaller one that had the plain numbers on the other side of the equal sign. So when I'm making my matrix A, my biggest matrix, I go in order of like the equations that I see here. So I have my first, my second, and my third equation. And so using a matrix happens mainly, like it's easiest to do mainly when I have 3 equations. You could do it like in a previous problem when we have 2 equations. But mainly when we have 3, because there's really no other shortcut, we can't graph these. Oh, I don't have X, Y, and Z. I have A, B, and C. So the first number that I have in front of A is 2. Then I have a 3 in front of the B, and then I see negative C, so that's a negative 1. Then in my second equation, I have a negative 4, I have a 9, and I have a 2. And then down here on the last equation, I have a negative 2 in front of A. I don't see a B. I don't see a B. I don't see a number in front of a B because I don't even see a B. So if there's no B's, that's 0. And then I have 2. In my other one, the numbers on the other side of the equal sign all alone are 1, 8, and 3. All right, so the way that I would solve this is I would go to desmos.com/matrix. Bro, matrix. And so I'll show you what that looks like, but I'm going to use this formula. So I would definitely write this down. And I'm going to show you how to use that right now. So I am in desmos.com/matrix. I'm going to do new matrix. I know that my first matrix has 3 rows and 3 columns, so I'm going to go here and change the number of rows and columns. I know I have a B matrix. It has 3 rows and 1 column. And I know that here I'm going to have A, then I have to click the A -1, and then B. And it'll give me my answer, but notice I don't have anything in there yet, so it's not giving me an answer. So I'm just going to go in here and copy down all the stuff that I had. So keep in mind that when you're showing your work, you do have to do this part. You do have to write down on your paper what you're seeing here, write down the formula you put in, and then you can write your answer. Right, and see now here it gives me an answer, and I can even put that as a fraction if I want to by hitting the fraction button. So this right here is my answer. 1/2, 2/3, and 2. All right, you guys are also going to see a word problem. So I'm going to read this and we are going to highlight the important information. If I see that it says a bakery sells 3 types of cookies, that's a hint to me that I'm going to use a matrix because this happens with 3 variables. All right, so then I look at the 3 different variables that I have, the 3 things I don't know. I have chocolate chip. We can say that chocolate chip is our X, oatmeal raisin is my Y, peanut butter is my Z. All right, this seems important. They sold a total of 100 cookies yesterday. All right, so that'll be definitely my first equation. Then my next sentence is the combined number. So combining usually means I'm adding. Oatmeal raisin and peanut butter cookies sold was 50 more than chocolate chip. Important. Then I have another sentence, so that'll probably be my third equation. If chocolate chip cookies sold for $1 each, oatmeal raisin cookies sold for $1.50 each, and peanut butter cookies sold for $2 each, the total revenue was $150. How many of each type of cookie were sold? All right, so let's go sentence by sentence and write our equations. So for the first one, they sold a total of 100 cookies. Well, X, Y, and Z represent the number of each type of cookie. So if in total, I add the number of chocolate chip, the number of oatmeal raisin, and the number of peanut butter cookies, it'll add up to 100. So I can just do X plus Y plus Z equals 100. Super easy. Oh my God, I can't write. Super easy. My second equation is a little more complicated. The combined number of oatmeal raisin and peanut butter cookies. Oatmeal raisin is Y, combined with peanut butter, which is Z, was, so that's a hint that I put an equal sign there, 50 cookies more than chocolate chip. So if I took that chocolate chip number and added 50. And then for my third equation, I see that the chocolate chip cookie sold for $1 each. So $1 times X plus $1.50 for each oatmeal raisin cookie, 1.5 times Y, plus peanut butter cookies, 2 times Z, In total, all of that money added together would be $150. Now I have my 3 equations that have 3 variables. How am I going to solve this? I'm going to use a matrix. First thing I have to check though is that all of my equations equal to 0. Or not equal to 0, equal to just a number. I don't want to have a variable on the side. So in my second equation, I do see that there is an x with the 50. I want to get rid of that x, so I'm going to move it over to the other side of the equal sign. So really, I've got, this stays the same, x plus y plus z equals 100. Now this changes to negative x plus y plus z equals 50. And then this is the same one. 1x plus 1.5y plus 2z equals 150. And so I make my matrices. I have 1, -1, 1. For the x's, I have 1, 1, and 1.5 for the y's. And then I have 1, 1, 2 for the z's. And for my b, I have 100, then 50, and then 150. So I go ahead and I'm going to type that into desmos.com/matrix and see what I get. I would highly recommend, and I'm sorry that this looks like such a mess, but I would highly recommend that instead of deleting everything, that you just like use the same matrix, just delete the numbers from this matrix, and use what you already have to do your next problem. Of course, you need to be double checking your points and everything to make sure you don't completely mess it up, but this would be the best bet. Right, so here you go. I plugged everything in and I find that my answers, we've got 25 chocolate chip cookies, 50 oatmeal raisin, 25 peanut butter. Yeah. Okay, so that's what we've got there. Our answers are 25, 50, and 25. So these are my answers over here. And that's how I do that problem. Pretty much ends what we'll see from topic 3, systems of equations. Moving on to briefly topic 1, the stuff that we're going to see mainly from topic 1, which was our second unit from the first 9 weeks, functions. The most important thing that we talked about was the characteristics of inverse functions. So the first important thing is that the x and the y values are flipped. I'd write this down. So if I look at this picture, I see the x values of my original function and the y values of my original function get flipped in the inverse. Then symmetric about y equals x, that just means that the picture of the graph gets flipped as if I took a piece of paper and folded it in half along the diagonal. So something like this. And then finally, the composition of f of x and its inverse is x. Now, you will see a question over this on your test. The most important thing to know is that if they are inverses, when you plug a function into another, it will just equal x. And so I don't think you can see this too well, but just know, this is super important. It is just going to equal x. Like, that's it. If everything turns out right, it equals x. So if you just see x at the end of a really long problem, that's a good thing. That means they're inverses. And you should write that down. Just saying. All right, so the whole flipping x and y thing, just as an example. So in my original problem, if I have 0, 2, 3, and 4 as my x values, in my inverse, those are going to be my y values. So 0, 2, 3, and 4. And in my original, my y values, -1, 0, 2, and 3, will be my x values for the inverse. So they literally just flip. And so the best way to check if graphs are inverses is looking at the points. So I always recommend looking at the points just to double check and making sure that they are inverses. So like here I have a graph, and then I'm going to graph the other points. And boom. They are inverses. So it also looks as if I had taken like this graph and folded it across the diagonal. That, it's the same shape, just folded across the diagonal. So they are inverses. All right, and then we are going to look at one simple example, finding the inverse. We'll see more later. So the biggest thing with finding the inverse, the biggest first step, after changing this to y equals, of course, our first really big step is switching the x and the y. That's kind of the whole thing with inverses, is switching x and y. So instead of y equals, this is going to be x equals 6y minus 2. After that, my next step is to just get the y alone. Now I have to solve for y. So I'm going to add 2 to both sides. So I've got x plus 2 equals 6y. And then finally, I'm going to divide by 6 on both sides. So we can have y equals x plus 2 over 6, or another way I can write this is x over 6 plus 2 over 6. Or finally, in the most simplest form. So here I was just simplifying it even more. This is also valid, and that would also give you credit. But I'm just saying, in case you see a multiple choice answer, this will probably be the final answer that you see. All right, that was really short. Moving on to topic 2, absolute value. This one kind of set us up the most for this the second 9 weeks. So this last really long unit that we were in, this kind of set us up the most. So this might seem familiar, but we'll talk about it. This is our absolute value function, topic 2. Third unit from our first 9 weeks. So when we're talking about attributes, we are talking about things like domain, so how far side to side a graph goes, which for absolute value functions, it is always going to be negative infinity to positive infinity. Then I also have the range, which the range is always going to be, where can I do this? All right, so it's always going to be either k to infinity if your graph is facing up, or from negative infinity to k if facing down. Okay, so that's something that's very important to notice if you haven't noticed that pattern already. Then I've got my x-intercepts. I can have 1, 2, or I can even have no x-intercepts. Then I've got my y-intercept where it crosses the y-axis. And then I have my vertex. Okay? All right, so please keep in mind that your x-intercepts are along the x-axis, and your y-intercepts are along the y-axis. Okay, so please be really careful to make a distinction between the two. And my vertex is h, k. So when I'm talking about k to infinity or negative infinity to k for my range, that is the y value of my vertex. Okay, and actually, I can also write this as y is greater than or equal to k, or y is less than or equal to k. So that number, that y value of that vertex is very important. So let's look at an example. So here, if I looked at this graph, if I were to look at it, it would look something like this. Okay. So first things first, domain is always, and I mean always, for absolute value. When I see these little bars, it is always going to be negative infinity to positive infinity, or all real numbers. Nothing changes about that. Right. If I look at my vertex should be at -1, comma, -4. So I know you can't see it down here, but that says vertex down here. Does say -1, comma, -4. Right, so my range does depend on the y value of my vertex. This is k. So since my graph is facing down, my range is going to be, you can write it like this, negative infinity to -4. Or you can also write it as all the y values that are less than or equal to -4, since it is facing down. For x-intercepts, I do not see it crossing the x-axis. So as far as x-intercepts go, we have none. Or actually, I'm a liar. I think that we had it green in our thingy. So this is our x-axis. And then we have none. So we're going to keep that green. Hooray. All right, and then for y-intercepts, I am checking where it crosses the y-axis, my vertical axis, and I find that it crosses right here, which would be -5. So my y-intercept would be 0, -5. Okay. So when I am doing maximum and minimum, and I'm about to show you how to do this in Desmos again, as a reminder for those of us who don't know. When we are doing maximum or minimum, sometimes it might be asking us on an interval, like this, with the brackets. When that happens, remember that I have to type it in Desmos like this. I have to put the less than or equal to x, less than or equal to 6. So what that's going to do is that is going to create some lines, and it's going to create a shaded area. Now on this graph, I do not have space, okay? It does not show me the whole picture, but I have a shaded area, and I'm going to be looking at the graph in that shaded area and seeing what the maximum and the minimum is. So let's hop over to Desmos and see what this looks like. All right, so I've typed it in Desmos, I typed in my function. Remember, you can type f of x equals, you can type y equals, you don't even have to type y equals, you can just type it like that, it doesn't matter. And then here, when I'm typing my interval, I want to have that format, that less than or equal to x, less than or equal to, and just change the numbers on the outside depending what the interval is. So the numbers that they give inside those brackets do tell me what numbers go on the outsides here. So it gives me this picture, and I'm looking at the shape of the graph inside of this shaded area. and I see the 2 points that it gives me. It gives me my highest point in this area, and it gives me my lowest point. So for a minimum or maximum, I only care about the y values. Y values. It's being so funky right now. Only the y values. So my minimum is my lowest y value in this area. My lowest point is this one, and the y value of that lowest point is -11. So this is my minimum. All right. And my maximum, my highest point is over here. The y value of that point is my maximum, which is -6. So that is how you would do maximum and minimum for a problem like this. All right, talking about transformations really quick. Let's reminder on what A, B, and, or not A, H, and K do. So starting out with A is that number in front of the absolute value lines. And when A is positive, so when A is a number bigger than 0, so when it's positive, that tells you that the graph is going to face up. So graph is concave up. So let's say concave up. All right. When A is negative, so when it's a number less than 0 or negative, that would be concave down. Or sometimes we see that written as reflected across the x-axis. So if that number in front is negative, it is reflected across the x-axis. The other things we look at with A is how big that number is. So if I look at the absolute value of that number and I find that it is bigger than 1, that is a vertical stretch, meaning it either gets skinnier or taller, narrower. So I'll write those things down. Skinny, narrow. All right. And if the number, the value of A is less than 1, that would be a vertical compression, which would be fat, wider. Okay. Then when I look at the inside, when I look at H, so X minus H, that does tell me, remember that if I do see X minus H, my graph will move to the right. And if I do see X plus H, that will mean my graph moves to the left. All right, and remember, H is also the X value of our vertex, so it's also pretty important in that regard. And then finally, I see K. Oh, shoot. No, go back. All right, K tells me how much I move up or down. So if I have plus K, that means we move up. If I see minus K, that means we move down. All right, so let's look at an example where we look at A, H, and K. So here, starting out by looking at A, so that's my number in front, I notice that this is a negative number. So because it's a negative number, so because -1/2 is negative, right, I find that this is going to be concave down or reflected across the x-axis. So Remember, A doesn't just deal with whether it's facing up or down, it also deals with if it's a stretch or a compress. Now I have to look at the absolute value of A. So the absolute value of -1/2 is 1/2. And 1/2 is smaller than 1. Now because it is smaller than 1, this is a compression. Then I look at, did my graph move left or right? So I look inside here, and I notice that it is x plus 5. So x plus 5 will move to the left by 5. Just remembering that it is opposite inside of those parentheses. And then finally, when I'm looking at up and down, I look at this plus 1 out here, my k, and since it is plus 1, that would be up. So really, you would just need to show me some kind of indication that you know where this came from. Okay, that you know where these changes came from. You knew where to look for them. That's mainly what I show, or what I ask you to show. If you know because of the plus 1, it moves up. Because of the x plus 5, it moves left, and stuff like that. All right, we are about to move on to the solving equations section, the solving absolute value equations. Remember that when we're solving for x, the goal is to get x alone. And so we reverse the order of operations, which is normally PEMDAS. The reverse of PEMDAS is SADMEP. So we'll always subtract or add first, then divide or multiply, then deal with exponents, and then the stuff that was inside of the parentheses. So let's take a look. So starting out here, remember with absolute value equations, I do have to make 2 equations. All right, but first here, let's start out just with a really simple one. We're actually not going to do this one because we'll see something similar. We will primarily do the other 3. So remember that for absolute value equations, I do have to make 2 equations. So one where it equals the positive version of the number and one where it equals the negative version. Okay? That is so horrendous because it is glitching. I am so sorry. It's glitching. Okay. So I have one where it'll be 4x equals positive 28. And then I'll have one where it's 4x equals negative 28. So remember, just to get x alone, I see that it's 4 times x. So I will divide by 4 on both sides. And for my first equation, my positive one, it is x equals positive 7. And for my other one, when I divide by 4 on both sides, I find that x equals negative 7. Okay, when I'm looking at my next question, again, I have to split it up into it equaling positive 4. And remember, once I do this step, I don't have to draw the absolute value lines anymore. So I have either negative 3x plus 2 equals positive 4, or negative 3x plus 2 equals negative 4. So I subtract 2 on both sides. I have negative 3x equals 2. And I divide by negative 3. So for my first answer, I get x equals negative 2/3. For my other one, I subtract 2. And I've got negative 3x equals negative 6. And I divide by negative 3. And I find that my other answer is x equals positive 2. So these are my 2 answers. Please forgive me for the mess, the technical glitches. And for my last example, absolute value of 2x minus 1 equals negative 5. Now, absolute value makes any number inside of it, makes it positive. So if absolute value can only turn stuff positive, an absolute value cannot equal a negative number. So this one actually has no solution because absolute value cannot equal a negative number. Let's look at one more problem, one that's got a little more going on to it. So when I have stuff outside of the absolute value sign, I am not ready yet to split it up like we were in the previous problems. I have to get it alone first. So what I'm going to do first is get rid of this plus 5 because it is outside of those absolute values. So I'm going to subtract 5 from both sides, and I see that I get absolute value of negative 3x plus 2 equals 4. Now that the absolute value lines are alone, I don't have anything outside of them. I can split it up now. So then I'll have negative 3x plus 2 equals positive 4. And then negative 3x plus 2 equals negative 4. And we find that it is very similar to a previous problem that we did. But basically now we can solve. So please always remember to get the stuff outside of the absolute value sign away. Get it alone. Okay? So that's all for part 1. So that is all of the stuff from the first 9 weeks that we are going to be covering on this video. I will end up doing a part 2, so a second video that is for the stuff from this last 9 weeks, which I mean we just took a test over it, but whatever, you'll get to see what specifically is on the exam. There will be practice / extra credit linked in Canvas. Of course, as always, show your work. But as always, let me know if you have any questions or if you want to see anything extra worked out from me in person. Okay, good luck.